Ocean, continuous body of salt water that is contained in enormous basins on Earth's surface. The ocean is the body of salt water that covers approximately 70.8% of Earth. The ocean is conventionally divided into large bodies of water, which are also referred to as oceans: the Pacific, Atlantic, Indian, Antarctic/Southern, and Arctic Ocean, and are themselves mostly divided into seas, gulfs, and subsequent bodies of water. The ocean contains 97% of Earth's water and is the primary component of Earth's hydrosphere, acting as a huge reservoir of heat for Earth's energy budget, as well as for its carbon cycle and water cycle, forming the basis for climate and weather patterns worldwide. The ocean is essential to life on Earth, harboring most of Earth's animals and protist life, originating photosynthesis and therefore Earth's atmospheric oxygen, still supplying half of it. Ocean scientists split the ocean into vertical and horizontal zones based on physical and biological conditions. Horizontally, the ocean covers the oceanic crust, which it shapes. Where the ocean meets dry land, it covers relatively shallow continental shelves, which are part of Earth's continental crust. Human activity is mostly coastal with high negative impacts on marine life. Vertically, the pelagic zone is the open ocean's water column from the surface to the ocean floor. The water column is further divided into zones based on depth and the amount of light present. The photic zone starts at the surface and is defined to be the depth at which light intensity is only 1% of the surface value, approximately 200 m in the open ocean. This is the zone where photosynthesis can occur. In this process, plants and microscopic algae, free-floating phytoplankton, use light, water, carbon dioxide, and nutrients to produce organic matter. As a result, the photic zone is the most biodiverse and the source of the food supply which sustains most of the ocean ecosystem. Light can only penetrate a few hundred more meters. The rest of the deeper ocean is cold and dark. These zones are called mesopelagic and aphotic zones. Ocean temperatures depend on the amount of solar radiation reaching the ocean surface. In the tropics, surface temperatures can rise to over 30 degrees Celsius (86 degrees Fahrenheit). Near the poles where sea ice forms, the temperature in equilibrium is about 2 degrees C, 28 degrees Fahrenheit. In all parts of the ocean, deep ocean temperatures range between 2 degrees C, 28 degrees Fahrenheit, and 5 degrees Celsius 41 degrees Fahrenheit. Constant circulation of water in the ocean creates ocean currents. Those currents are caused by forces operating on the water, such as temperature and salinity differences, atmospheric circulation, wind, and the Coriolis effect. 16 tides create tidal currents, while wind and waves cause surface currents. The Gulf Stream, Kuroshio Current, Agulhas Current, and Antarctic Circumpolar Current are all major ocean currents. Such currents transport massive amounts of water, gases, pollutants, and heat to different parts of the world, and from the surface into the deep ocean. All this has impacts on the global climate system. Ocean water contains dissolved gases, including oxygen, carbon dioxide, and nitrogen. An exchange of these gases occurs at the ocean's surface. The solubility of these gases depends on the temperature and salinity of the water. The carbon dioxide concentration in the atmosphere is rising due to CO2 emissions, mainly from fossil fuel combustion. As the oceans absorb CO2 from the atmosphere, a higher concentration leads to ocean acidification, a drop in pH value. The ocean provides many benefits to humans such as ecosystem services, access to seafood and other marine resources, and a means of transport. The ocean is known to be the habitat of over 230,000 species, but may hold considerably more, perhaps over 2 million species. Yet, the ocean faces many environmental threats, such as marine pollution, overfishing, and the effects of climate change. Those effects include ocean warming, ocean acidification, and sea level rise. The continental shelf and coastal waters are most affected by human activity. The terms the ocean or the sea used without specification refer to the interconnected body of salt water covering the majority of Earth's surface, i.e., the world ocean. It includes the Pacific, Atlantic, Indian, Southern/Antarctic, and Arctic oceans. As a general term, the ocean and the sea are often interchangeable. Strictly speaking, a sea is a body of water, generally a division of the world ocean, partly or fully enclosed by land. The word sea can also be used for many specific, much smaller bodies of seawater, such as the North Sea or the Red Sea. There is no sharp distinction between seas and oceans, though generally seas are smaller, and are often partly, as marginal seas, or wholly, as inland seas, bordered by land. World ocean. The contemporary concept of the world ocean was coined in the early 20th century by the Russian oceanographer Yuli Shokolsky to refer to the continuous ocean that covers and encircles most of Earth. The global, interconnected body of salt water is sometimes referred to as the world ocean, global ocean, or the great ocean. The concept of a continuous body of water with relatively unrestricted exchange between its components is critical in oceanography. Scientists believe that a sizable quantity of water would have been in the material that formed Earth. Water molecules would have escaped Earth's gravity more easily when it was less massive during its formation. This is called atmospheric escape. During planetary formation, Earth possibly had magma oceans. Subsequently, outgassing, volcanic activity and meteorite impacts produced an early atmosphere of carbon dioxide, nitrogen, and water vapor, according to current theories. The gases and the atmosphere are thought to have accumulated over millions of years. After Earth's surface had significantly cooled, the water vapor over time would have condensed, forming Earth's first oceans. The early oceans might have been significantly hotter than today and appeared green due to high iron content. Geological evidence helps constrain the time frame for liquid water existing on Earth. A sample of pillow basalt, a type of rock formed during an underwater eruption, was recovered from the Ijua Greenstone Belt and provides evidence that water existed on Earth 3.8 billion years ago. In the Nouveau-Jitic Greenstone Belt, Quebec, Canada, rocks dated at 3.8 billion years old by one study and 4.28 billion years old by another show evidence of the presence of water at these ages. If oceans existed earlier than this, any geological evidence either has yet to be discovered, or has since been destroyed by geological processes like crustal recycling. However, in August 2020, researchers reported that sufficient water to fill the oceans may have always been on the Earth since the beginning of the planet's formation. In this model, atmospheric greenhouse gases kept the oceans from freezing when the newly forming sun had only 70% of its current luminosity. The origin of Earth's oceans is unknown. Oceans are thought to have formed in the Hadean Eon and may have been the cause for the emergence of life. Plate tectonics, post-glacial rebound, and sea level rise continually change the coastline and structure of the world ocean. A global ocean has existed in one form or another on Earth for eons. Since its formation, the ocean has taken many conditions and shapes, with many past ocean divisions and potentially at times covering the whole globe. During colder climatic periods, more ice caps and glaciers form, and enough of the global water supply accumulates as ice to lessen the amounts in other parts of the water cycle. The reverse is true during warm periods. During the last ice age, glaciers covered almost one-third of Earth's land mass, with the result being that the oceans were about 122 meters 400 feet lower than today. During the last global warm spell, about 125,000 years ago, the seas were about 5.5 meters 18 feet higher than they are now. About 3 million years ago, the oceans could have been up to 50 meters 165 feet higher. The entire ocean, containing 97% of Earth's water, spans 70.8% of Earth's surface, making it Earth's global ocean or world ocean. This makes Earth, along with its vibrant hydrosphere, a water world or ocean world, particularly in Earth's early history when the ocean is thought to have possibly covered Earth completely. The ocean's shape is irregular, unevenly dominating the Earth's surface. This leads to the distinction of the Earth's surface into a water and land hemisphere, as well as the division of the ocean into different oceans. An ocean is a continuous body of salt water that is contained in an enormous basin on Earth's surface. The major oceans and their marginal seas cover nearly 71% of Earth's surface, with an average depth of 3,688 meters, 12,100 feet. The five major oceans are the Pacific, Atlantic, Indian, Arctic, and Southern Oceans. The Pacific is the largest ocean in both surface area and volume. The Atlantic is the next largest, and the Arctic is the smallest. The planet has one global ocean, though oceanographers and the countries of the world have traditionally divided it into five distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. Beginning in the 20th century, some oceanographers labeled the seas around Antarctica the Southern Ocean, and in 2021 National Geographic officially recognized this fifth ocean. An estimated 97% of the world's water is found in the ocean. Because of this, the ocean has considerable impact on weather, temperature, and the food supply of humans and other organisms. Despite its size and impact on the lives of every organism on Earth, the ocean remains a mystery. More than 80% of the ocean has not been mapped, explored, or even seen by humans. A far greater percentage of the surfaces of the Moon and the planet Mars has been mapped and studied than of our own ocean floor. Although there is much more to learn, oceanographers have already made some amazing discoveries. For example, we know that the ocean contains towering mountain ranges and deep canyons, known as trenches, just like those on land. The peak of the world's highest mountain, Mount Everest in the Himalaya, measuring 8.85 kilometers, 5.49 miles, high, would not even break the surface of the water if it was placed in the Pacific Ocean's Mariana Trench or Philippine Trench, two of the deepest parts of the ocean. On the other hand, the Atlantic Ocean is relatively shallow because large parts of its seafloor are made up of continental shelves, parts of the continents that extend far out into the ocean. The average depth of the entire ocean is 3,720 meters, 12,200 feet. It is unknown how many different species call the ocean their home. With many marine ecosystems suffering from rising sea temperatures, pollution, and other problems, some oceanographers believe the number of species is dropping. Still, there may be many positive surprises waiting for oceanographers in the years ahead. It could be that more than 90% of the ocean's species are still undiscovered, with some scientists estimating there are anywhere between a few 100,000 and a few million more to be discovered. Currently, scientists know of around 226,000 ocean species. Learning more about the seafloor and the rest of the ocean is the passion of National Geographic explorer Marcelo Callisti. He is a biorobotics expert who is developing an undersea exploration vehicle that uses legged locomotion, inspired by the way an octopus moves underwater. His long-range goal is to design robots that can explore the depths that are difficult for humans to reach. Since the ocean is so vast, there is plenty for future oceanographers from all corners of the globe to explore and discover. Thank you for watching this video.